Hello students, till now I have given you two problems in form of shorts and few of you have asked for solution. So here I am solving those two questions. At least I will give you hint. If I will not solve it completely, I will give you hint. This is the first question. These are two smooth inclined planes. Both are inclined at an angle of 45 degree to the horizontal. If I release a small block from the top of this inclined plane, it takes time t1 to reach here at the bottom. And similarly, when I release a block on the top of the second plane, it takes time t2 to reach here at the bottom. And the question is, if I release these two blocks simultaneously from the top of the respective inclined planes, what will be the smallest separation between these two blocks? Now, before I solve this question, I will give you a rather simple question. Think about it. Suppose this is x axis and this is y axis. There are two particles. This particle 1 is moving with a constant velocity of let us say 4 meter per second or 2 meter per second in y direction, and then there is another particle here which is moving with a velocity of 2 meter per second in negative x direction. At time t is equal to 0, this is the position of these two particles. Particle 1 is here, particle 2 is here, and distance between them, particle 1 is at origin, particle 2 is somewhere on y axis, and distance between them is, let us say, 10 meter, right. This particle keeps moving with constant velocity of 2 meter per second. This also keeps moving with constant velocity of 2 meter per second in negative x direction. Now, the same question. What will be minimum separation between these two particles during their course of journey? Now, this question, though it can be answered in multiple ways, but one very simple way of looking at this situation is by looking at motion of one of the particles from the reference frame of the other particle. What I mean to say, suppose there is an insect sitting over particle 1, there is a small ant sitting over particle 1. Now, this particular ant will find herself at rest, but what will be velocity of particle 2 for this particular ant? इस ऑब्जर्वर को particle 2 की velocity क्या दिखेगी? So, in physics, we say that velocity of 2 relative to 1 is actually v2 minus v1. How do you calculate this? You calculate this by adding minus v1 vector to v2. Now, what is v2? What is v2? v2 is a velocity of 2 meter per second in this direction. You have to add minus v1 to this v2. Minus v1 stands for a velocity of 2 meter per second in this direction, reversed. So, looking carefully, this is v2 and this is minus v1. If we add these two vectors, you get a vector of magnitude 2 root 2, making an angle of 45 degree with either of x and y axis like this, right. This implies that if there is somebody sitting over here, I mean there is an observer located on this particle 1, then that particular observer will find herself to be at rest, and it will see that this particle 2 is traveling in this direction with a constant velocity of 2 root 2. So, in this particular reference frame, in this reference frame of particle 1 is not moving, but this particular particle 2 is actually moving in this direction, making an angle of 45 degree like this. Can you see that? This is velocity of 2 relative to 1. This is velocity of 2 relative to 1. So, in this reference frame, this is at rest and this is traveling at a constant velocity of 2 root 2 in this direction. So, obviously, what is the smallest distance between these two particles? This is a fixed point and this particular point is moving along this line. So, how do we get the smallest distance? From this point, drop a perpendicular here, and this is the smallest distance, isn't it? So, if this is 10, this angle is 45, this is smallest distance is 10 by root 2, that is 5 root 2 meter. This is our answer, as simple as that. So the same thing can be used in this particular question also. Many of you may be tempted to try this question once again. Yes, in that case, pause the video and give it a try. What's wrong in that? The question says that if a particle is released from here, it takes time t1 to reach here. It is a smooth inclined plane, so I hope all of you understand that acceleration will be g by root 2, g sin theta. So this particle travels with a constant acceleration of g by root 2 and takes a time t1 to reach bottom, which means length of this inclined plane x1 is nothing but half g by root 2 half a t square. This is the length. And similarly for this particle, if you consider the motion, acceleration is again g by root 2 and that particle takes time t2. So length of this inclined plane x2 can be similarly written as half g by root 2 t2 square. So you know the length of these two inclined planes, which means you know the initial distance between these two particles when they were released simultaneously. This x is the initial distance between these two particles, and this x is nothing but x2 minus x1. So x2 minus x1 means g2 root 2 t2 square minus t1 square. So this is the initial separation between the two particles. Now what is the situation? The situation is that there is one inclined plane, this is another inclined plane. This particle begins to move in this direction at an acceleration of g by root 2. This particle also begins to move in this direction at an acceleration of g by root 2. This is 90-degree angle. And initial distance between them is x, which is known to us. So what will be minimum distance between them? Just in a way similar to the example that I have cited, we can solve this question very easily in reference frame of one of the particles, right? For example, if I call this as particle 1 and this as particle 2, suppose there is an observer located on the particle 1 itself. What kind of motion of 2 will that particular observer see? So initial velocity of both the particles is 0. So initial velocity of 2 relative to 1 is 0, no doubt about it. But what is acceleration of 2 relative to 1? What is acceleration of 2 relative to 1? It is obviously a2 minus a1. Now how do you calculate a2 minus a1? a2 is this vector g by root 2 minus a1. This is vector a1, flip it, reverse it, this is minus a1 vector. It also has got magnitude g by root 2. This also has got magnitude g by root 2. Both are at right angle. So add these two vectors, a2 minus a1, right? So if you do a2 minus a1, what do you get? You get a horizontal vector like this in this diagram. And its magnitude will be root 2 times of this. Am I making sense? It will be root 2 times of this. Acceleration of this one is g by root 2, acceleration of this one is g by root 2. I am looking at this whole situation from the point of view of an observer located on particle 1. If there is an observer located at particle 1, he or she will not find particle 1 to be moving. But what will be relative acceleration that he or she will see for particle number 2? So that is given by acceleration of 2 minus acceleration of 1. So acceleration of 2, this is the acceleration of 1, I invert it and add these two vectors. The resultant will be in this diagram I am showing. The resultant will be like this. This is acceleration of 2 with respect to 1, and its magnitude will be obviously under root this square plus this square, which is g itself. होगा ना भाई? Simple है. So for this particular observer, initial velocity of this particle is 0, right? and this particle is traveling horizontally with some acceleration g. This is not moving. If the observer is located here, वो खुद नहीं चल रहा है, but particle 2 appears to be moving in this direction. So again, what is the smallest distance? This is fixed, this is traveling in this direction, drop a perpendicular. This is the smallest distance. This is the smallest distance. And what is that? This angle is 45 degree. So this is nothing but x by root 2. So you know the value of x. You have already calculated the value of x somewhere here. So x by root 2 will be your answer to this question. I hope you all have understood this. Now the another question that I have asked is somewhat like this. I do not remember the exact diagram that I did draw on that day, but it was somewhat like this. This is a plane mirror. This is a plane mirror, and there is some object over here. Let us say O is center point, and at a distance r from this center point, there is some object A or P kept here. Right? This angle is given. It hardly matters actually. Okay. Can all of you tell me where is the image of point P? If required, you can extend the mirror. I hope you all know this. And image of point P will be at same distance from the mirror on the other side at this particular location P dash. It is important to note that in case of a plane mirror, if this is object, this is the image, this distance is x, this distance is x, that's fine. The perpendicular distance of the object and image from the mirror is same, that's fine. The another fact is, which is very obvious now, that you take any point A on the mirror, you take any point A on the mirror, the distance of object from this point and distance of image from this point, these two distances will also be same. You take any point on the mirror, this point, distance of object, this object from this particular point and distance of this image from this particular point, that will also be same always. So whatever be the distance of point P from O, the same is the distance of image from point O. This distance will remain same. For that matter, if you take O to be here, then also these two distances will remain same. That is one thing. Another important thing that you must be knowing is actually this. You all must be knowing that if this is point P, then there are many rays which hit the mirror and get reflected. All reflected rays appear to be diverging from the image point, right? This ray goes like this, and if you extend it backward, it appears to be coming from the image point P dash. So we can take multiple such rays, right? I am drawing one more ray. There is another ray that is incident on the mirror. This ray also, after reflection, appears to be diverging from this image point. So that is how image is formed. All of you must be knowing this. Now, if I rotate this mirror by some angle theta, then angle of incidence of all these rays, I mean ray 1 or ray 2, this is true for any ray in fact. If I rotate this mirror by an angle theta, the angle of incidence of any ray, any particular ray, will change by theta. And you have studied that in such a case, the reflected ray deviates by 2 theta. That means if I rotate this angle by 30 degree angle, then for each and every ray the angle of incidence will change by 30 degree, and this particular reflected ray will get deflected by 60 degree. Any reflected ray will get deflected by 60 degree if you rotate the mirror by 30 degree. When mirror is rotated by theta, each and every reflected ray will get deviated by 2 theta from its original position. ये रे जो इधर जा रही थी, अगर मिरर को 30 डिग्री घुमा दोगे तो यही वाली इंसिडेंट रे जो इसकी रिफ्लेक्टेड रे की पोजीशन है, इससे 60 डिग्री इधर हो जाएगी. ये वाली रिफ्लेक्टेड रे भी अभी जिस पोजीशन में उससे 60 डिग्री इधर हो जाएगी। तो भाई जरा कॉमन सेंस से सोचिए कि अभी मैंने 2 ही रेज दिखाई, आप 500 दिखा सकते हैं कि ये रे 1 और 2 दोनों को, इस दोनों चीज को अगर मैं 60 डिग्री के एंगल से घुमा दूं तो क्या ऐसा एहसास नहीं होगा कि ये जो पॉइंट पी डैश है ये वो एक फिक्स पॉइंट है, ओ के रेस्पेक्ट में ये पी डैश जो है ये 60 डिग्री के एंगल से घूम गया। क्या होगा? ये दोनों रेस का मीटिंग पॉइंट इमेज है। अगर इन दोनों रेस को पकड़ के मैं ऐसे 60 डिग्री घुमा दूं तो ये पॉइंट तो 60 डिग्री ही घुमा ना। तो ऐसे कॉमन सेंस से हम ये समझा सकते हैं दुनिया को कि भाई अगर ये मिरर थीटा एंगल से टिल्ट करोगे, घुमाओगे तो ये जो रिफ्लेक्टेड रेस है ये 2 थीटा से घूम जाएंगी, तो ये जो इमेज पॉइंट है ये भी 2 थीटा से घूम जाएगा, राइट? विच मीन्स इफ द एंगुलर स्पीड ऑफ द मिरर इज ओमेगा, then the angular speed of this image point is 2 omega. If mirror rotates by 30 degree, this point rotates by 60 degree. If mirror rotates by 20 degree, this point rotates by 40 degree. So if the angular speed of mirror is omega, this particular image point is rotating with an angular speed of 2 omega. Therefore, the speed of this particular point with respect to O, यहाँ O पे अगर बैठ के आप देख रहे हैं so this point rotates. O is just a fixed point on the table. Don't get confused. O is not a point that is rotating with mirror. O is a fixed point on the table. It's not. We are not talking of rotating reference frame. So if with respect to O, if you look at this point, if the mirror tilts by an angle theta, this point will rotate by 2 theta. So if the mirror has an angular speed omega, this point has an angular speed 2 omega, and this distance being r, somebody sitting here will see that image p dash is rotating at an angular speed of 2 omega on a circular path of radius r. So the speed of point p dash will be 2 omega into r, isn't it? If you have not understood this, then I'll give you another way of thinking, approaching this. Maybe those of you who are in class 11th and have not studied optics, who are not convinced with the fact that when mirror rotates by an angle theta, the reflected ray rotates by 2 theta. If you have not studied that, it's quite easy, you can prove it on your own. But even then, if you don't bother to study, you can think like this. Let us have a look here. This is point P. Okay, fine. The question says that mirror is rotating with angular speed omega, right? Now let us think of an observer. Who is in a reference frame that is rotating with the mirror. Think about an observer who is rotating with the mirror with an angular speed omega. Think from the point of view of that observer, right? Now from the point of view of that observer, mirror is at rest. But this particular point is rotating with angular speed omega in opposite direction. Think of an observer who is in a reference frame that is rotating along with the mirror. For that particular observer, the mirror is at rest, whereas this point is rotating with an angular speed omega in opposite direction. But for that observer, mirror is at rest, point to be noted. So if the mirror is fixed in that frame, and the image point, let us say, object point keeps moving on a circular path with angular speed omega, in that reference frame, the image point will also rotate with angular speed omega. This is common sense. The mirror is fixed now, mirror is not moving because we are in reference frame that is rotating with mirror. So for that observer, if this is object, this is image. If this is object, at the same distance, this is image. So for that particular observer, this object point P is rotating like this and the image will be rotating like this with same angular speed omega. So with respect to this observer, the image is rotating in this direction with angular speed omega with respect to this observer. And now this observer himself is rotating like this. इस ऑब्जर्वर के रेस्पेक्ट में इस पॉइंट की एंगुलर वेलोसिटी ओमेगा है और ये ऑब्जर्वर खुद ही एंगुलर वेलोसिटी ओमेगा से चल रहा है, तो ग्राउंड के रेस्पेक्ट में इसकी एंगुलर वेलोसिटी क्या हो गई, 2 ओमेगा। ये वैसा ही हो गया ना भाई, जैसे ये कार है, सॉरी ये एक गाड़ी है जो 10 की स्पीड से चल रही है, और इस ऑब्जर्वर को एक मोटरसाइकिल 10 की स्पीड से चलती हुई दिख रही है। इस ऑब्जर्वर को मोटरसाइकिल 10 से चलती हुई दिख रही है, तो मोटरसाइकिल की एक्चुअल स्पीड विथ रेस्पेक्ट टू ग्राउंड क्या है, 20 है। तो मिरर के साथ रोटेट करने वाले फ्रेम में इमेज की एंगुलर स्पीड ओमेगा है, और ये रेफरेंस फ्रेम खुद ओमेगा एंगुलर स्पीड से घूम रहा है, तो भाई उसके ग्राउंड के रेस्पेक्ट में इसकी एंगुलर स्पीड 2 ओमेगा हो गई। तो ग्राउंड के रेस्पेक्ट में जो इमेज है वो 2 ओमेगा एंगुलर स्पीड से घूम रहा है, तो फिर से उसकी स्पीड कितनी हो गई, 2 ओमेगा इंटू आर। इट डजेंट मैटर कि शुरुआत में या मिरर थोड़ी देर बाद 10, 20, 25 डिग्री के एंगल से घूम गया, उस समय इमेज पॉइंट की स्पीड तो वही रहेगी। सो आई होप all of you have understood this, and thank you for watching this video. If you have not subscribed, please do, and also like the video. Thank you.